Whoops. Now it's on. All right, iodine. 7, oxygen. 6, barium. 2, thank you. All right, underneath barium, aluminum. 3, hydrogen. 1, xenon. 8, and copper. 1. 1 or 2? 1. Okay. All right, so now that we have that, those are called the valence electrons. They are on the very outside energy level. Now we are going to draw the Lewis dot diagrams for them. Did I mention this for you before? Yeah. Okay, so let's go ahead and flip that over. And let's draw the Lewis dot diagrams for these elements. I'll do the first one with you, then you can do the rest by yourself. Calcium, we're going to write the symbol down. And then how many dots is it going to get? 2. 1, 2. If you put the dots both on top for the first 2 dots, that is acceptable. So just know that they could draw it like this and it's still acceptable. Okay? All right. Try the next couple on your own. Let's see what you got. Shouldn't take you too long. Let me just pause the tape so I can walk around. Back on it again and write the answer. So potassium should have 1 dot. Argon should have 8 dots. Aluminum should have 3 dots. Bromine should have 8 dots. Carbon should have 4 dots. Helium should have 2 dots. Oxygen has 6. Phosphorus has 5. Hydrogen has 1. How'd we do? All good? All right, moving right along. Now, we're going to start manipulating some of these electrons. Okay? We are going to look at ions and draw the Lewis dot diagram of the ion. Now, when we have an ion, what are we doing? Making a charged particle. So we are going to either add or subtract electrons from it. So let's take a look at sodium. I'm going to make my pen a little fatter. Sodium has 1 valence electron. Okay. It generally has an electron configuration of 2-8-1. That's its electron configuration. Well, if I take the electron away, this electron right here, and I remove that electron, what happens to the charge on this sodium? It becomes positive. Good. So I'll go back to black pen. Now that sodium has no electron on it, and the charge is going to become positive. Okay. When we draw it as a Lewis dot diagram for the ion, and this is important because we're going to start drawing compounds soon and we have to know how to draw these. When we draw them as the ion in the Lewis dot diagram, we have to put them in these brackets with the charge on the outside. This is the Lewis dot diagram for a positive ion. The one has lost its electrons. So you'll see it written like this. This is not the Lewis dot diagram. This is just the atom with its charge. If you're drawing the Lewis dot diagram to indicate that it has lost its electrons, it must be in these square brackets. Let's do calcium. Calcium has an electron configuration of 2-8-8-2. So normally it would have 2 valence electrons. 1, 2. If it becomes a calcium ion, which is a calcium plus 2, what does the Lewis dot diagram look like? Well, it's going to be the calcium symbol with no electrons around it because it lost those electrons. And you're going to end up putting it in the brackets with a +2 charge on the outside. That's the Lewis dot diagram for it. Okay? So if you have a positive cation that has a that you need to draw the Lewis dot diagram of, it's going to have no dots around it, and it's going to be in brackets. All right, now let's do the opposite. Let's go to the other side. Let's do fluorine. Fluorine generally has 7 valence electrons. And its electron configuration is going to be 2-7. Well, it wants to gain an electron to become a fluorine with a -1 charge. So when it gains that electron is going to go in this space. Right here. You see it? I'm drawing it as an X so you can indicate that it's a different electron. Well, now it's got 8 electrons around it. So what we're going to do is we're going to take the fluorine, we're going to put the electrons on there with the extra one that it gained. I'm going to put it in brackets, and I'm going to put a -1 charge on it. That's the Lewis dot diagram. That's what it looks like for a negative ion. Let's do oxygen. Oxygen has an electron configuration of 2-what? 6. Let's draw the Lewis dot diagram for an oxygen -2. You're going to have oxygen. It's going to have 6 valence electrons that belongs to it. And it is going to gain 2 more. That's how it got the -2 charge. We're going to put that sucker in brackets, and we're going to put a -2 charge on it. Pretty easy, right? Okay, so when we gain or we lose electrons, we're going to indicate it with a charge, and if we're drawing the Lewis dot diagram, we have to put it in brackets. Here, I'm not including the electrons, so I don't have to worry about it. I'm just writing oxygen. All right. Let's take it one step further. You ready, Jacob? Okay. Let's do sodium and chlorine. Okay. Don't draw anything yet. Just watch for a second. So if you have sodium, and that sodium has 1 valence electron, and you've got chlorine, and that chlorine has 7 valence electrons. I'm going to make these little X's just so that you can see that they're different. Okay? And these guys get together on a dark, stormy night. What is going to happen? Chlorine is going to take the sodium's electron. So what happens is this electron is going to go over here. Okay? And you're going to end up with a sodium with a +1 charge and a chlorine with a -1 charge. Now, when I draw it in Lewis dot diagram form, it's going to look like this. Sodium in brackets with a +1 charge, and chlorine with, let's keep it consistent and let's keep them red. Woo! Woo! Chlorine. And I made these black, so I'll do that. And then this guy is going to be in square brackets with a -1 charge. Okay? You just made your first compound. Okay? Now, right between the positive and the negative, there is an attractive force because opposites attract. This right here is called an ionic bond. Why do you think it's called an ionic bond? What's this thing called? An ion. And what's this thing called? An ion. Okay? An ionic bond is made between a positive ion and a negative ion. Good? Okay. All right. Now you can copy that down. It's your first ionic bond. My first ionic bond. It's like baby's first birthday or something like that. It is always made between a positive ion and a negative ion. All right, I'm going to point out one more thing. When you have an ionic bond or a compound that is formed, the overall net charge has to be 0. So here I have a +1, and here I have a -1. No electrons are left out in the wind all willy-nilly. They have to have some place to go. So if somebody loses electrons, somebody else has to be gaining them. The other thing I want to point out is that there are only 2 things here, and you have to make it work with those 2 things. Okay? So there'll always be 1 cation and 1 anion. 1 cation and 1 anion. Okay, let's try another one. Let's do magnesium and bromine. I'm writing the words out because I don't want to write the Lewis dot diagrams. I want you to. So let's do magnesium. How many valence electrons is it going to get? 2. Uno, doso. Okay. Bromine. 7. Okay. Magnesium wants to do what? Lose how many? 2. Bromine, just look up here and think. Bromine wants to gain 1. If magnesium is losing 2 and bromine is gaining 1, there's 1 electron that doesn't have a place to go. So how are we going to fix that? Well, instead of having 1 bromine, we're going to actually have 2 bromines. These electrons are going to move over there. And so now I've got 1 magnesium. What's the charge on that magnesium? How many electrons did it lose? 2. So its charge is +2. And these bromines, what's the charge on that 1 bromine right there? The one that you can see. What's its charge? Minus what? 1. -1. Good. And what's the charge on this bromine down here? -1. Notice that these numbers add up to what? 0. And that's what we want them to do. Okay? So we just made our second compound. Pretty cool, right? Okay. For sure. All right, let's write this in formula. Let's write this as a formula instead of the Lewis dot diagram, and then I'm getting ahead of myself, so we're going to backtrack just a little bit. Okay? So how many magnesiums do I have here? 1. So magnesium, I'm going to write it down. There is a number in the bottom right corner. We haven't talked about these numbers yet, right? When they're in a formula, that's called a subscript. It tells you how many magnesiums you have. Right now, how many magnesiums do I have? 1. That's good. All right, now let's do bromine. Bromine. How many bromines do I have here? 2. So I'm going to put a 2 down here as the subscript. That means there are 2 bromines. Each bromine has a -1 charge. Each magnesium has a +2 charge. Understand how I wrote that. There's 1 magnesium here. It has a +2 charge. There are 2 bromines here. Each one of them has a -1 charge. That's what this means. Okay? Got it? Do you see how this adds to 0? This bottom number, I'll write the 1 in. This bottom number, 1, +2, and 2 -1s. That's huge when we write formulas down. Okay. Any questions on that so far? Okay. So that's the beginning of writing our first compounds. Now we're going to backtrack just a little bit. Okay. We have looked at what happens to an atom if I gain electrons or if I lose electrons. What happens to the atom when the electrons start jumping around? Not gaining them, not losing them, but when they're moving energy levels. Okay. So let's take, I don't know, calcium, for instance. Calcium. Okay. Its electron configuration is 2882. That electron configuration, write this down, is called the ground state electron configuration. You already know where this is going because we talked about it already. It is the ground state. It's saying that the electrons are in the lowest possible energy levels. What happens if I put energy into this calcium? What do the electrons start to do?
Go up.
They go up. Okay? When they go up, the electrons are either going to jump to new energy levels up here that are not written in, or electrons down here are going to jump to a higher energy level. The easiest way when they ask you to write the electron configuration where the electrons have jumped up to higher energy levels, the best way to do this is to take an electron off of the last energy level and give it its own energy level. So if I went from Ca, which is 2882, to Ca, which is 28811, the electron that used to be here jumped up to a higher energy level. Did it change its charge? No. It didn't change its charge because it still has the same number of electrons that it had before. They're just in different rings. Okay? This, I'm going to change colors just so that you don't get confused, is called the excited state. And the excited state means electrons have jumped to higher energy levels. Can it stay there? No. What happens when it goes from the excited back down to the ground? It gives off light. We talked about that already. Okay? You're going to see that in the lab. Maybe I'll break it out. We're not going to do the lab this week only because we have to turn the gas on for it and you have to light the Bunsen burners. So I'm saving it kind of for the beginning of next week. But I'm going to show you something tomorrow with excited state. Okay, what about if they give you an electron configuration like 2-8-1? Okay, just hold off for a second. I want to know, A, what element it is. B, is it ground or excited state? So how are you going to figure this out? Alex, you know which one it is already? Okay, don't say anything yet. Sean? Hi. Yeah. So what element do you think this is, Sean? Let him figure it out for a second. What element do you think this is? And then tell me why you think it is that. Calcium? Why sodium? And do you want to answer why it's sodium? It matches the electron configuration on the periodic table. Okay? So this is how you're going to do it. You're going to add all these suckers up. 281. That adds up to 11. When you look at the periodic table on or in your reference tables, if I can find one, here it is. Okay, let's go down to the periodic table, rotate, and you look at sodium, it says 281. Okay, if it matches it, it's ground state. They are giving you the ground state electron configuration for every single element on the periodic table. What about if I had given you 272? What element is that going to be? Go ahead, Alex.
Sodium.
It is still sodium. How did you know it was still sodium?
Because that E8 electron level is not full.
It's not full. Okay. Let's make it even easier for people. Total amount of electrons is still 11. And protons equals electrons in a neutral atom. These are neutral atoms. We are not talking about gaining or losing electrons. We are talking about electrons moving energy levels. So this guy still has 11. This guy still has 11. And like Alex said, what happened here was that electron that used to be here jumped up to a higher energy level. They're going to give you an electron configuration, and they're going to say, A, what element is it? B, is it ground or excited state? This one is excited state because it does not match what is on the reference table. If it matches what's on the reference table, it is ground state. If it doesn't match what's on the reference table, it is excited state. Okay? Let's do 266. If I give you 266, what element is it? And is it ground or excited state? Ange? It's not silicone. Oh, yes, it is. Sorry. It is silicone. And it's excited state. So 2, 6, that's 12 plus 2 is 14. So you go over here to 14. You say to yourself, self, does it match what's on the periodic table? No. So it is excited state silicone. Okay? It is not an ion. It is excited state silicone. What about if they said, give me an excited state electron configuration for magnesium? Give me one excited state electron configuration for magnesium. You can give, there's lots of them. 273. Looks good to me. 2811. Looks good to me. Anybody want to do anything else? How about 184? Does that work? Yeah. Still adds up to 8. No, that doesn't work. That's not right. 18. what am I doing? So, which one am I doing? I'm doing silicone? I'm doing magnesium. I got confused for a second. So 282. Okay. So 183. Does that work? Yeah, that's magnesium. So it adds up to 12, but it doesn't match what's on the periodic table. What about this? 192. What's wrong with that? There can only be 8 in the second ring. Watch that. That's why I'm saying to you the best way to do this is to look at the ground state and always take one off of the last ring and just pop it up to a brand new ring, and then you never have to worry about overfilling anything. Okay? All right, ground, excited state. Any questions on that?